Hello everyone and welcome to Kognito Key. Today we're going to unravel a really clever piece of engineering that solves a classic electrical puzzle.
It really does sound like a riddle, doesn't it? You've got three distinct power phases, but you only have 2 meters to work with. I mean, common sense would tell you you're going to miss a third of the information, right? Well, it turns out there's an incredibly elegant solution that works just perfectly.
So how on earth is this done? The answer is a brilliant technique called the Two Wattmeter Method. It's a classic engineering shortcut that's not just clever, but also surprisingly accurate.
So what is it, exactly? Well, at its core, this method lets you measure the total power in a three-phase system using just 2 meters. But here's what makes it so incredibly powerful. It works no matter how the load is connected, whether it's star or delta. And crucially, it works even if the load is unbalanced, which, let's be honest, is a huge deal in real-world applications where things are rarely perfect.
And you know what? The setup itself is beautifully simple. You just connect the current coils of your 2 watt meters to any 2 of the 3 lines. Then, the potential coil for each meter connects from its own line to the 3rd line, which acts as a common reference point. And that's pretty much it. The total power for the whole 3-phase system is just the reading from meter 1 added to the reading from meter 2.
Okay, so that's the theory. But what does this actually look like when you put it into practice? Let's start with a star-connected load, which is a really common setup you'll find all over the place.
This diagram shows it all perfectly. See how wattmeter 1 is kind of watching the current on line R while using line B as its voltage reference? At the very same time, wattmeter 2 is doing the exact same thing for line Y, also using line B as its reference. That 3rd line basically becomes the anchor for both measurements.
So each meter is really only measuring one slice of the picture. One is focused on line R, the other on line Y. But here's the magic. When you simply add their 2 readings together, you get the total power for the entire 3-phase system. It really is that straightforward.
But this is where it gets really clever. You might be thinking, okay, a delta connection is different, so I'd probably need a different setup, right? Well, it turns out the exact same method works perfectly here too.
Just take a look. Even though the load itself is wired completely differently in a delta formation, notice the watt meters. Their connections are identical to the star setup. The current coils are in the same lines, and they're still referencing that same common 3rd line. This versatility is what makes the method so robust and reliable.
And the calculation is, once again, exactly the same. You take the reading from the 1st meter, add it to the 2nd, and that's your total power. The fact that the internal wiring of the load doesn't change the measurement process at all is what makes this method such a fundamental tool for any electrical engineer.
So, we've seen that it works for both star and delta connections. But that brings up a really important question. What makes this particular method shine? Why is it such a go-to technique?
Well, it all comes down to practicality. First, using fewer meters means less equipment, which means lower cost. Second, its ability to handle unbalanced loads is critical because real-world systems are almost never perfectly balanced. And finally, since you don't need a neutral wire, the setup is just simpler and cleaner. It's a smarter, more efficient way to get the job done.
This quote really gets to the heart of why it's so trusted. The sum of the 2 readings isn't just some clever guess. It's mathematically equal to the actual instantaneous power of the whole system. Now, of course, a physical meter has a needle with inertia, so what it ends up showing you is the average power, which is exactly the measurement we're looking for anyway.
So, to quickly recap everything, we started with a puzzle. 3 phases, but only 2 meters. We found the solution in this elegant method, we saw how it works seamlessly with both star and delta loads, and we understood the practical advantages that make it so popular.
This leaves us with a fascinating thought. The 2 wattmeter method is a perfect example of pure engineering ingenuity. You know, doing more with less. It makes you wonder, if 2 meters are all you need for 3 phases, what other clever shortcuts are hiding in plain sight, just waiting to be discovered?
Thanks so much for joining us. If you found this breakdown of the 2 wattmeter method helpful, please be sure to like, share, and subscribe to Kognito Key for more deep dives into these key concepts. We'll see you in the next one.